This is Anand Kumar Singh. Today we are going to discuss a very important metric which is known as discrete metric. Hope this lecture will be helpful to you to build a better understanding of metric and metric space. Let's start. If X be a non-empty set and D maps X cross X to R be a function such that d of x comma y means distance between x and y is equal to 0 if x is equal to y and is equal to 1 if x not equal to y for all values of x comma y belongs to x, then D is a metric on X called discrete metric, and x comma d is said to be discrete metric space. So guys, the definition of a discrete metric is D of x comma y is equal to 0 if x is equal to y and 1 if x not equal to y for all values of x comma y belongs to x. Discrete metric means if we take any two points from the set x, if the points be equal, then obviously the distance between these points will be 0 by the property of a metric space. And if we take any two distinct point from x, then the distance will be equal to 1 no matter what type of points we are going to take it. Okay, now we are going to verify that D is a metric space. To show D is a metric, we are going to verify the four properties of a metric space. Now, what are the four properties? The four properties are: first is D of x comma y is greater than or equal to 0 for all values of x comma y belongs to x. Second property is D of x comma y is equal to 0 if and only if x is equal to y for all values of x comma y belongs to x. The third one is D of x comma y is equal to D of y comma x, symmetric property for all values of x comma y belongs to x. And the fourth property, D of x comma z is lesser or equal to D of x comma y plus D of y comma z for all values of x comma y comma z belongs to x. So guys, we are going to verify that D is a metric on X, and for this we have to verify all the four properties. So we are going to start from the first property, which is D of x comma y is greater than or equal to 0. From the definition of the function D of x comma y is given as 0 if x is equal to y and 1 if x not equal to y for all values of x comma y belongs to x. And it is clear from here that the distance function is either 0 or greater than 0. It means that D of x comma y is greater than or equal to 0. So from the definition of D, it is clear that distance between any two point of the set x, is either equal to 0 or greater than 0. So the first property to form a metric is satisfied here. Now the second property, what is this? This is if D of x comma y is equal to 0, it will imply x is equal to y, and if x is equal to y, then we will get D of x comma y is equal to 0. For this property, let if x is equal to y, then it will imply from the definition if x is equal to y, from the definition we will get D of x comma y is equal to 0. If x is equal to y, then from the definition we will get D of x comma y is equal to 0. So if x is equal to y, it will imply x comma y is equal to 0. And if we take x not equal to y, then as from the definition, x not equal to y means d of x comma y is equal to 1. From the definition, x not equal to y, it means d of x comma y is equal to 1. So if x not equal to y, this will imply x d of x comma y is equal to 1, which also means that d of x comma y is not equal to 0. So by contrapositive statement, d of x comma y is equal to 0, which will imply x is equal to y. Combining this and this, we will get d of x comma y is equal to 0 if and only if x is equal to y, for all values of x comma y belongs to x. So guys, if we take x is equal to y, it will imply d of x comma y, distance between x and y, is equal to 0 from the definition, which is given that d of x comma y is equal to 0 if x is equal to y. So x is equal to y implies that d of x comma y is equal to 0. If we take x not equal to y, then we will get d of x comma y, distance between x and y, is equal to 1. Distance between x and y is equal to 1, which implies that d of x comma y not equal to 0. So by contrapositive statement, d of x comma y is equal to 0, which will imply x is equal to y. D of x comma y is equal to 0 implies that x is equal to y. Combining this one with this one, we will get d of x comma y is equal to 0 if and only if x is equal to y, for all values of x comma y belongs to x. So the second property is also satisfied here. Let's go for the third one. The third property to form a metric is known as symmetric property. Let us consider d of x comma y here, which is given by 0 if x is equal to y and 1 if x not equal to y, or all values of x comma y belongs to x. From here we can write it like this: 0 if y is equal to x, 1 if y not equal to x. It is very clear from here that if x is equal to y, we can also write it y is equal to x. X is equal to y can also be written as y is equal to x, and x not equal to y, it also means y not equal to x. And this will give us d of y comma x. D of y comma x. From the definition, if x is equal to y and x not equal to y, we will get d of x comma y. If y is equal to x and y not equal to x, we will get y comma x, or all values of x comma y belongs to x, or all values of x comma y belongs to x. So d of x comma y, so d of x comma y is equal to d of y comma x, for all values of x comma y belongs to x, is also satisfied here. The third property to form a metric is also satisfied here. So let's move for the fourth one. For the fourth property, we are going to consider some sub cases. Let us consider, at first, before considering some cases, what we have to show. If we will take x comma y comma z belongs to x, 3 points from the set x, then the triangle inequality property or triangular property to form a metric, it implies that d of x comma z is lesser or equal to d of x comma y plus d of y comma z. Okay, for all values of x comma y comma z belongs to x, if we take any 3 point from the set x, then this inequation will be satisfied by x, y, z. So we are going to show this inequality, which will be satisfied by d. It is known as triangular property of a metric or triangle inequality. And for this, we are going to take some sub cases. Let us consider case 1. Case 1. And for this case, we take x is equal to y is equal to z. For this case, we are going to take x is equal to y is equal to z. X, y, z is from x. x, y, z are taken from the set X. If x is equal to y, y is equal to z, then what will be the outcomes? At first we have to find d of x comma z, d of x comma z. D of x comma z is equal to, since x and z are equal points, then from the definition x is equal to y, what we will have? D of x comma y is equal to 0. Okay. Now d of x comma y, since x and y are equal, then we will also get d of x comma y is equal to 0, and it's same for d of y comma z is equal to 0 because of y and z are also equal. So at first d of x comma z is equal to 0, which can be written as 0 plus 0 again, and 0 is here d of x comma y also, plus this 0 can be written as d of y comma z. So guys, d of x comma z is equal to d of x comma y plus d of y comma z. So the case 1 gives that d of x comma z. The case 1 gives that d of x comma z is equal to d of x comma y plus d of y comma z. If we consider x is equal to y is equal to z, if the 3 points be the same points, then d of x comma z is equal to d of x comma y plus d of y comma z. Let us take the case 2. That is x is equal to y not equal to z. Let us consider here the second case, x is equal to y not equal to z. Then what will be the outcome? If we consider here x is equal to y not equal to z, then it also implies that x is not equal to z. If we take x is equal to y not equal to z, since y not equal to z, then it also implies that x not equal to z. Okay, d of x comma z, since x not equal to z, then we will get 1 as its outcome, because of x not equal to y implies that d of x comma y is equal to 1. X not equal to y implies that d of x comma y is equal to 1. Since x not equal to z, then distance between x and z will be 1. X and y, since x and y same are the same points, then distance between x comma y will be 0, because of from the definition d of x comma y is equal to 0 if x is equal to y. D of y comma z, since y and z are not equal, then outcome will be 1, because of d of x comma y is equal to 1, d of x comma y is equal to 1 if x not equal to y. Since y not equal to z, then outcome will be 1. So d of x comma z is equal to 1, which can be written as 0 plus 1. 0 means d of x comma y, distance between x and y, plus 1. 1 means d of y comma z, distance between y and z. So d of x comma z is equal to d of x comma y plus d of y comma z. Now let us consider a third case. From the second case, x is equal to y not equal to z, we will get d of x comma z is equal to d of x comma y plus d of y comma z. Let us consider a third one. That is x not equal to y is equal to z. If we consider a third case, x not equal to y is equal to z, then it will imply, since x not equal to y, then x not equal to z also. Since x not equal to y, then it implies x not equal to z also. So d of x comma z, since x not equal to z, then outcome will be 1. D of x comma y, since x not equal to y, outcome will be 1. D of y comma z, since y and z is considered here as equal points, therefore the outcome will be 0. following the definition. X not equal to z, x not equal to z, x not equal to y means d of x comma y is equal to 1. So x not equal to z means 1. D of x comma y is equal to 1 as x not equal to y, and d of y comma z is equal to 0 because of y and z are equal. Since x is equal to y implies that 0 outcome. So d of y comma z is equal to 0 as y and z are equal points. So d of x comma z is equal to 1, which can be break as 1 plus 0 is equal to 1 is here d of x comma y, d of x comma y, and 0 is here d of y comma z. So it also can be written as d of x comma z is equal to d of x comma y plus d of y comma z. So from the third case, considered as x not equal to y is equal to z, x not equal to y is equal to z, we have got d of x comma z is equal to d of x comma y plus d of y comma z. Let us consider a fourth one. We are going to consider another case. The case number is 4. That is x equal to z not equal to y. Since we have considered here x is equal to z not equal to y, it also means x not equal to y also. From here d of x comma z is equal to, since x and z are equal, therefore x is equal to y means output will be 0. d of x comma y is equal to, since x and y are not equal, then we are damn sure about the outcome, it will be 1. And d of y comma z is equal to, since y and z are not equal, then outcome also will be 1. So d of x comma z is equal to 0, and d of x comma y plus d of y comma z is equal to d of x comma y, what is it? 1, and d of y comma z, it is also 1, is equal to 2. 1 plus 1 is equal to 2. So d of x comma z and d of x comma y plus d of y comma z is equal to 2. As 0 less than 2, it implies that d of x comma z is less than d of x comma y plus d of y comma z. As d of x comma z is equal to 0 and d of x comma y plus d of y comma z is equal to 2. As we know that 0 is less than 2, so 0 means d of x comma z, and 2 means here 2 means d of x comma y plus d of y comma z. So d of x comma z less than d of x comma y plus d of y comma z. Let us consider another case, which is case number 5, taken as x not equal to y not equal to z. And for this case, d of x comma z is equal to 1, d of x comma y it also equal to 1, and d of y comma z it will also be 1, because of x not equal to y means outcome will be 1, y not equal to z means outcome also will be 1, x not equal to z means outcome will be 1, because of, from the definition it is clearly given that x not equal to y means outcome is 1, x not equal to y means outcome is 1. So d of x comma z is equal to 1, and d of x comma y plus d of y comma z is equal to 1 plus 1, which is equal to 2. As 1 less than 2, as 1 is less than 2, so d of 1 less than 2, 1 means here d of x comma z is less than 2 means here d of x comma y plus d of y comma z, d of x comma y plus d of y comma z. So guys, Now combining all the five cases for x, y, z taking from the set X, we are going to get d of x, z is lesser or equal to d of x, y plus d of y, z. If we combine all the five cases, then the outcome or the result will be d of x, z lesser or equal to d of x, y plus d of y, z. So all the four properties to form a metric is satisfied here by D. Since D satisfies all the four properties to form a metric, therefore D is said to be a metric on the set X. And the metric D with the set X, is known as the discrete metric. D is called here discrete metric, and the set X with the metric D is called discrete metric space. Okay guys, if you like this video, please support us. Next time, the next video will be coming soon. Okay, bye.